Welcome everyone. My name is Mr. C. Behind the camera is Mr. Don, and we are here to present to you today another STEM video. Science, Technology, Engineering, and Mathematics. What we're going to do is an activity together that you can easily do at your schools, at your homes, that answers the question, are packages engineered? Things like cereal boxes, even milk jugs, other boxed items of things you see at the grocery stores. Okay, there's the question we're trying to answer by doing this activity. What you need very simply is, or are, the templates, because we're going to create different packages as you see in front of me. These are the packages. So there's templates that we can provide for you of each shape. Okay. Container with some dry beans. I guess you could also use rice, but dry beans are nice. I like them because then we can make beans and eat them if you want. All right. First, I want you to predict which of the packages, which of the shapes of these packages will allow you to hold the most beans. Do you think it's the pyramid? The solid figure called pyramid? Do you think it's the cube? Do you think it would be the triangular prism? Would hold more of these beans than any of the other packages shapes? Or the rectangular prism? Make a prediction. Jot down some notes in a science journal, mathematics journal. It's all about science, technology, engineering, and mathematics. They all blend well and work nicely together very well. Fill one of the packages now to the top with beans so that the lid can still close. So I'm going to fill, like it shows in the diagram, the pyramid. All the way to the top. And make sure that, okay, so it can still close. All right. Then what you do is pour the beans directly into another package. So let's start with the cube. Doesn't matter where you start. I like this activity too because it's material. You use materials that are easily found at the home. You also, everyone can be a part of it. Okay, you saw the few beans spilled, so make sure you get them in there. The key is, does this package hold more than this one? So we must be able to close the lid flat. And I'll give you a nice view in a second. Okay, so you write down which one between the pyramid and the cube can hold the more beans. We can't close this one's lid. All right, so make your notes. We'll go back to this one again. Empty, all the beans. Now, can the pyramid hold more or not as much as the triangular prism? And I'll be more careful how I pour this time, right? Scientists and engineers, mathematicians they work with practice. They get very good at measuring. They get very good at doing things eat carefully. This could be chemicals, for example, right? All the beans. And I hear you, Mr. C. You dropped a bean. Just one this time, better average. Okay. I can close that very easily. So now, I'm observing anyway, that it's very close to the pyramid and the pyramidal prism, or the triangular prism. We're trying to answer, are packages engineered? We know they are, and they're engineered for various reasons. You know, if you're trying to get the more product, for example, into a package, which shape would you use? There's other factors to consider when you're designing a package. Now we have the rectangular prism and the pyramid. Okay, I dropped 3 beans this time, so let's get those up there into our package. And this time I cannot close the lid, okay? So we know that this one holds more beans than the cube and the rectangular prism, okay? What I'm not clear on, and what scientists would do, engineers would do, they would test this again, because it appeared that we could close this lid when we filled the beans up to the top. We could also close this lid. So what do you have to do now to determine which package can hold the most beans, if that was your goal? It's my goal. Well, I'm gonna fill this up to the top again. Refill the beans into this pyramid package, pyramid-shaped package. I didn't pat them down last time, but I'm just going to do it loosely like we did. Spread it out. A few off of there, because again, all right, it's pretty good, pretty good. Let me take a few more off. Again, there's no hurry, and this would include, you can include the whole family with activities like this, and I love it. Okay, now we got it, all right? Closes easily, up, stick it out there, okay? Yeah, closes easily. So now, between these two, we're just comparing. Once again, it's either this one or this one that holds the more beans. Boy, to look at it, you would think, which one? You've already predicted that, right? I have a... It's not by much. It's not by much. But when I was taking a little bit more care into how I added the beans to the package, I find that when I add the beans now to this triangular prism, it won't close. And what we also could have done is what? We could have simply just set these to the side, since it was between these two, and we could have counted the beans. Each time we filled what was in this, how many beans were in this container first, this package, and then compare to how many can fit in this package, this triangular prism, okay? So if you're an engineer, which package shape would you use to make it appear that it holds the most product? Which one just looks like it holds the most? Maybe that's your goal. You don't necessarily want the most, but you want your package to look like it holds the most. Which one would you pick? And you can write down why. Okay? What a great way to infuse literacy, writing. Now, which package would you use so that when you put your product in the package, they stack more easily on the shelf, the packages. They more easily stack on the shelves. Did you pick this one? Stacking on a shelf, okay? And you can explain why. In a drawing, a couple phrases, a sentence or two, you can explain why, okay? Now, if you are an engineer and you were hired to design a package that had a shape that attracted the most attention because they feel it's a unique shape, right? So which one would you choose? Which are the design packages would you choose because you think it's the most unique shape and it would attract attention to your product that goes in the packages or package? All right, now for a little engineering connection. Okay, surprise, all the package shapes hold about the same number of beans. Why do engineers decide to use one shape instead of another? So we discovered a little bit different results, but these packages are all supposed to hold about the same number of beans. I would love to hear your results if you try this or when you try this activity. Engineers put a lot of thought into developing packaging for the products we buy. Which materials to use, how much the package costs to make, is it attractive, does it protect the product, what is the impact on the environment, and much more. With more and more products being created, package engineering is a field with lots of opportunities. Now, we are very, very blessed and fortunate to have such great engineering schools here in the state of Michigan. We have Wayne State University here in Detroit. We have the University of Michigan, several campuses. We have Michigan State University. We have Lawrence Tech University, Michigan Tech. So I hope you enjoyed this activity, and because you get different results, or some of the results that may not be what we expected, is okay. You make hypotheses and you learn by doing. In this case, you really want to be able to do the activity. And with the paper that you need, the dried beans, and we have the templates available, why not, right? So this is Mr. C, and behind the camera is Mr. Don. Thank you again for welcoming us into your world, and we appreciate you, okay? Put us to work, teachers, educators, and we'll see you again for another Detroit Children's Museum video. Thank you.